welcome back to another episode of the AI and Kubernetes show. I'm your host, William Morgan. I'm the CEO of Buoyant. We make an incredible service mesh called Linkerd, but we're not going to talk too much about that today. Instead, we're going to talk about the exciting and fun-filled intersection of Kubernetes and generative AI. I am privileged today to be joined by Ron Petty. Ron, welcome to the show.
Thank you, William. Glad to be here.
All right, for our audience of Kubernetes experts and platform engineers, can you introduce yourself and just justify why you are relevant to their existence?
Why am I here? In short, my day job is consulting around cloud native tech for a long period of time at a company called RXM. We're one of the original companies to be involved with the creation of the CNCF. Along that path, we were also responsible for a lot of the certifications related to Kubernetes. Fun fact, when we created the CKA, all of us took it and all of us failed it the first time after we created the test.
This is like test-driven development, right? You create the test first and you're supposed to fail it, and then you improve the code to the point where it passes the test. So I assume
we made it easier for us.
Oh, you made the test easier. I thought you just improved your knowledge.
Oh yes. That's kind of my longer path inside of Kubernetes. Prior to that, I was involved in various forms of high performance computing and finance and academia. And then beyond that, I'm also very involved with the community. Obviously, the CNCF is a community, but also other communities, including the ACM, IEEE, Internet Society, where we partner with groups like the CNCF to teach people things like what is cloud native development all about. Now, specifically of all this stuff, I'm involved with the CNCF TCGAI group, which is the Technical Community Group for AI, formerly the CNCF AI Working Group. And the point of this group is more or less, I used to describe it as a traffic cop. This is where, we have hundreds of projects in the CNCF. They're looking for guidance on what does it mean to do AI, just learn AI, integrate it with their particular, projects or not. Sometimes the answer is you shouldn't do anything just because you're great the way you are. So there's that kind of stuff. So we do presentations, on this kind of ecosystem of AI, how it's evolving. And that's really what my interest is in this particular realm is I've been doing an ongoing report on basically how things are evolving. So looking at the projects, which again, there's hundreds of them in the CNCF. And then of course, the larger cloud native world, which is thousands and thousands of projects. Can't watch them all, but trying to see what the trends are regarding the construction and consumption of AI in cloud native.
Okay, so this is a group that's in the CNCF. So obviously, in the Kubernetes ecosystem, the charter is to understand, map out AI within that ecosystem.
That's right, and it's evolved now because things just the technology has evolved, right? So this kind of started out as a working group to see what should we be doing. Now it's evolved into this thing they have called the Technical Community Group, where I don't want to call it a salon-like experience, but basically instead of us doing the work and writing the white papers, what'll happen is we'll get ideas for these things, and then we'll go find the even more technical experts of the particular aspects. So if it's AI and networking, we'll go to the tag for networking, right, and deliberately work with them, and that's kind of the form of it now.
Okay. And then just so I understand, I've been in the CNCF ecosystem for a long time, but I'm never involved in anything as highfalutin as working groups or TCGs. There are a bunch of other working groups, and then are there also a bunch of TCGs, technical community groups?
That's right. So there's I don't know the exact number, but there's 7 or 8 TCGs now, and there are things like workloads, security, kind of like the high general categories of things. And then from there, they try to manage the message from the CNCF. So if we're going to produce research or something around, say, security, we want to make sure we have security people together, meeting often, trading notes, that kind of thing, and reviewing whoever happens to be authoring these kinds of papers and research.
And is there like an evolution of these groups? Is it like there's a working group and then there's a TCG and then there's something else, and
Yeah, so there's an evolution here. Working groups, as it kind of implies, is meant to just be a working group doing some task.
Yeah.
And it should have a beginning, middle, and an end. It's not meant to be something that lasts forever. From my understanding, the AI working group probably lasted longer than it should have, as far as a member of the bureaucracy of the CNCF. So ultimately, we sunsetted that just I don't know, maybe 6 months ago, as they launched the TCGs, which again are basically, they're just trying to put more guidance on, like, not everybody knows everything, right? So where could you or should you go? They're trying to be a little more formal about things. Working groups still will pop up, but now they might be subgroups of the TCGs. Then, of course, above all this, you have the tag and then the TOC, which is the overall steering committee for all technical concerns in management.
Okay. All right. The senior management in this hierarchy of groups. Okay. So great. So one kind of term that I've heard bandied about is cloud native AI, and I remember in the early days of Kubernetes, there was a lot of talk about, like, well, what does cloud native mean? And, like, to be cloud native, do you have to be on Kubernetes? Could you be on Mesos, for example, which was a popular thing in the early days, and still be cloud native? And and I know that there was a lot of, like, discussion and a desire to kind of formalize with them. And is there a similar thing happening with, like, cloud native AI? Is there a desire to, like, formalize? What does it mean if we say the terms cloud native AI? Does that have some definition?
We have attempted at a definition. So one of the working group artifacts was a white paper, so it's a couple of years old now. But that was actually one of the main parts of it, is trying to define, like, what is cloud native AI. So in short, and again, this is very skewed towards my take on it, but I also heavily influenced that.
Well, you're on the podcast, so you get to view it however you want.
Well, kudos to my buddies, Ricardo and Boris and everyone else who helped with this. Basically, to me, there's kind of two sides to this. There's cloud native AI, and then there's AI for cloud native. So it's just easier to have one definition. So that's why most people don't think of it as a two-way street. But I think it's very much a two-way street. There's the things that are producing AI, like training a model. And then there's using it for, like, inference. And the reality is there's even more than that. If you're going to categorize the projects in the CN ecosystem, there's ones that are like, can I just use it in one of those two regards, right? It's a piece of the puzzle. It's a piece of the pipeline. But then there's the idea that you could even extend it through maybe a plugin, right? A lot of things are very open, like, oh, you can run arbitrary scripts. So I can make a script that does a little loop in a bash script that, calls an LLM. And now all of a sudden it's agentic too, even though I didn't change anything about a project that's been stable for 10 years, right? So again, what does that even mean? Like, is that a good thing, a bad thing? So there's other levels of classification. And so really how I kind of classify it is, at a high level, again, are you capable of relatively easily building AI models and things like that, or not? It's really not even got anything to do with cloud native. It's just, has the system as an overall thing, it made that easy. So, we've got things like Kubeflow, which are purpose-built tooling in the cloud native space to make it more of a manageable process. Kubernetes, of course, itself, you mentioned Mesos, there's Swarm, there's other things like, are these all requirements to be cloud native AI? I don't think so. I think they're just the popular options. Obviously, Kubernetes is used in a lot of places. I think the last kind of industry report is something like 60% of all major AI building operations use it. Then, of course, it makes you wonder, what's the other 40 doing, would you call that cloud native? I don't want to get too hung up on the word cloud native. To me, I like to keep things simple. You're using containers in some way, and they may be on somebody else's computer or yours, and they're scaling somehow. We like to say things like Kubernetes, but to me, that's just a form, maybe a very popular form. But as somebody who came from high performance computing long before Kubernetes ever existed, it's not the only game in town.
Sure.
But obviously, it's an important one. Um,
But
but today,
containerization is
that's
like
shifted.
bar for you. That's the threshold. Like if you're using container, what if you're using containers and you're just like using three of them and you like hard code their names and you know,
Yeah.
isn't
Well,
there ultimate
I I
orchestration?
I like to remind people, because I do a lot of consulting, that a lot of people feel they need to build these auto scaling systems,
Yeah,
which I know is part of the cloud native official definition. Um, but I'm also of the belief that the amount of time it took you to learn that, you could have had the intern use a hard coded thing for free and quickly. So I think there's a big gap. And what's what's good about the gap here, even today, is that's an opportunity still. Like I'll just give a concrete example of something I think the industry is completely foobarred, that cloud native slash AI might be able to fix, hopefully. And that's certs, right? Certificate management rotation. I'm of the belief, if certs were so important, if encryption was so important, why is it not automated out of the box in your operating system? Why do humans need to be involved at all? We're all doing the exact same thing, creating root certs, intermediate certs, leaf certs, rotating them, giving them different, organization units and common names. We're all doing the exact same thing. Nobody's doing anything special. Why are we all still doing it with totally different tools? I mean, yes, there's Let's Encrypt. Yes, there's Vault. Yes, there's things like that. But that's my point. Why do we have 100 ways to do the exact same thing and still get it wrong? Right? People still mess it up. People still have to do that, and that's just one. That's just one common aspect. There's plenty of other things that should be common, yet we're all doing ad hoc things again, like
yeah, yeah. No,
software bill of materials.
you're speaking my language with the cert stuff because that's obviously a big reason why people use Linkerd is because they want
Yes.
mutual TLS. They want it to happen magically, and they don't want to have to get into the gory details. And so, yes, we can do a lot of that for you. Unfortunately, even with Linkerd, there's still some stuff where, we have to call out the cert manager. You have to figure out, and even today, what's funny is we introduced, and now this is like a total aside from AI, but it's part of my it's part of my justification for being around. Even we introduced mutual TLS kind of on by default in Linkerd in like 2018 or 2019, like very, very early on. And even today, we're still adding kind of like bits of infrastructure to automate things like, rotation of trust anchor certificates through my clusters and things like that. So it's still, we're still, there's still a lot more to do, to make it easy to manage certs at scale. But yeah, it does feel like, I feel like there's this principle in security where if you make it hard to do something that's secure, then people aren't going to do it, right? Like if you make them change their password every 7 days, or you make them pick some like, you know, complex system where you have to have one of this and one of that, but not one of those or whatever, then they're just gonna, they're gonna figure out a way to like cheat the system. If you make it easy to do the right thing, then of course they'll do it.
That's right.
Okay. So, when I think about AI workloads on Kubernetes, well, whether or not they're on Kubernetes, I guess I kind of mentally I partition it into kind of three buckets. There's training, there's the actual running of inference, and then there's like the doing stuff with the inference, right? And we roughly call running or training, inference, and like agents. Well, agents, I think there's a lot of ambiguity in what that means. Are those all kind of, if you're doing those things on Kubernetes, I guess those are all like cloud native AI, or would you refine
Yeah.
it within there? Is there something else in there that I'm missing?
No, I'd agree with that as a high level sentiment. Yeah, there's the creation and setting up, which is what I think we're mostly referring to with the create a model or host it for inference. But at the end of the day, the hosting doesn't do anything for you unless you're calling it, right? So you got to build the software to actually use it, right? Or else it's moot. Um, so yeah, absolutely. And that's really where all the action is today for the bulk of the world, right? And it makes sense. Like not everybody can build a model of any quality. It's a very tough game to get into for lots of reasons. But anyone can now, well, even without AI, we have automation, right? In fact, that's a part of a lot of the kind of just general research I'm into is it ain't, to me, it ain't about AI. Yes, that's the hot commodity today, but automation's been a thing for forever and centuries. So it's just another way, right, to automate in some degree. So I know my view is not the same as a lot of people's, but that's how I see it. And so the agent stuff is great. But there's lots of things we still have to just figure out there, right? Ignoring the creation of models, which is still evolving. Hosting has its challenges too, of course. I think if you even took AI out of the equation and asked somebody, could you automate your environment? Even in 2026,
Yeah.
most people cannot hit a single button to relaunch their enterprise, right? No matter how many people had working on it, right?
Is that a thing that AI can help with? Can you say,
Absolutely.
hey, you'll figure out how to reproduce this environment?
Absolutely. I think in part of maybe the message there is it will help you simplify it. I think part of the problem is people overcomplicate things. And I get why. If you're someone like me, I suffer from shiny object syndrome, right? So I'm like, yeah, let's do that because it's not lunch yet, right? And we'll just go do it. Other people are much more stoic, right? They stick to the plan. And I think that's where a lot of that kind of, ambiguity of execution comes in. So AI hopefully will be like, hey, you're doing something in 20 steps. You could actually do that in 3 steps if you kind of do this way. And I'm not saying it's always right, but that actually leads to another thing that I'm very interested in, and that's validation, right? We have all these things about seeing, checking is AI right. I'm not only worried about one answer from AI. I'm worried about like you told me to make 50 different corrections and each one of them has to be verified in its own unique way. The combination of that has to be verified in its own way. To me, that whole game, if you want to call it, is completely underdeveloped. And at the end of the day, AI or not, it doesn't even matter how we got there. We have to have better tools to tell us what is going on and is it correct. That to me is where quite frankly, all the real work's going to be in the next several years, especially because agents, everybody's creating all these things, doing all these things, but nobody can actually tell how it's doing it, or if it's doing it well, or if it's even doing it right.
Right. Yeah. It seems like, if anything, the need, and I had a really interesting conversation. Listeners, this is an earlier podcast with one of the founders of TestCube, about how kind of the dynamic has shifted a lot, or at least, this is my interpretation. It used to be, we're talking about like unit tests or whatever. It used to be, okay, you write the code, that's the important thing. And then afterwards you're like, all right, let me add some unit tests to like, kind of make sure I got coverage. But the tests were kind of throwaway code. And now it seems like there's been an inversion of that. The code now is free, at least kind of in some sense, right? You can just have Claude go write it. But how do you know whether it's right or not? Well, the tests now suddenly are really, really important. And it seems like that extends to, kind of every aspect of the environment. If you're running some agentic workload like on your cluster, you're pretty much guaranteed that thing is like, it's going to do something it's not supposed to do, right? Like in a way that you could kind of get away with when the code on your cluster was written by humans and it was all like, code reviewed and whatever, you had some, yes, you should put security guidelines in place and guardrails, but you can make some assumptions that like, okay, it's probably fine. Or if someone's trying to do something, that's because they're being malicious. With, once you have this stochastic LLM in there, those guarantees go away, right? It seems like it's just a matter of time before it tries to do something it's not supposed to do. So any kind of guardrails, validation, testing you can put in there, it feels like the value of that has gone up in a world where the actual execution is less someone driving their car in a straight line and more, someone like looking at their phone while they drive. I'm in Texas, so like this is what I see on the streets all day. But like, you know,
Our
well,
Waymos at least drive
imagine the
straight. They're
guardrails
looking
are very
ahead.
important here. You don't have guardrails, like no one would survive. Yeah. Do you think how important do you think it is to have a definition for what cloud native AI is? Is it a thing that's important because people want to get that stamp on their project and like officially certified cloud native AI by the Linux Foundation? Or is it an important thing just because we need to have like some common terminology? Or like where,
I think the latter. I mean, I love the Linux Foundation and the CNCF. I mean, was involved with the Linux Foundation even well before the CNCF. I was involved with Linux well before that. I think at the end of the day, you got to be able to at some level group things, and so yeah, I think having that stamp of approval helps. It'd be one thing. I mean, I was saying earlier, a lot of things are kind of ad hoc, which shouldn't be, like cert management, but on the same token, we all know we're talking about TLS, right? Or digital cert. If we didn't have that common vernacular, it would be even more chaos. So, Kubernetes is great. I also, it brought a lot of people into, like, quite frankly, doing distributed computing to some degree. Is it the same thing as the top 500 supercomputers and MPI and that kind of stuff? No, not really, but it's also not wildly different, right? And so it's, I think a lot more people were exposed to a lot more because of that common vernacular. So I definitely think it's useful. AI is suffering a bit from that. One that I love arguing with people about is about agents and life cycle controls and things like this. Like, what is it? Like, what definitions, taxonomy is important or not? Like, there's a huge, I don't know why everybody's gun ho about talking about long running agents, and I'm like, why? What's different about? And again, this is my opinion. What is different from worrying about a long running agent versus one that's short running? Right? To me, all things being equal, moving at the speed of light, whether it took a millisecond or a nanosecond to accomplish the task, are both going to have similar complexities. So why just focus on one kind of time horizon? And the reality is you're not going to care 5 years from now that your agent failed. You're going to care that it broke today, right? And so to me, like, to spend all this time worrying about these long-term concerns, I think it's absolutely important, but I don't think, like, for some reason, the agent industry is really harping on long-term everything. And I'm like, the reality is that won't matter till you're there.
Is it code word for, so you're much more deeply embedded in the space than I am, but is it word for like, a short-term agent is something that I'm going to kind of monitor real time? Like, I'm going to tell it to do something and then I'm going to get back, an answer in a couple minutes, and then I'm going to, like, turn it off. Whereas a long-term agent is something that's going to run while I'm sleeping. So who knows, whatever it's doing, like, I might not even be there. Or is it something, is there something more to it?
No, I think that's the gist of it. I think people are kind of just summarizing that this thing's going to live forever, like a daemon, right? It's going to run forever and do when it does its things, versus some other regime. But to me, the mistake is we're going to label agents as being a long running concern. And that is not true. Most agents are going to be a short-term concern. The value of what they give you usually is now. I'm buying a plane ticket now. Yeah, I may have set rules a year ago, like, don't make me go broke when you do it. But when you do it, it's now. And so you could argue the whole thing is a long-term agent. I get that. But the real work all happens in one kind of short time slice. And so I think we're elevating it to an unnecessary position of power when agents should just be any kind of workflow at any time scale.
Let's talk about, like, this definition, especially I kind of mentioned can I get a stamp from the Linux Foundation that says I'm AI certified or something? In the past, there's been this, like for Kubernetes, there's been, and for other projects, there are these very strict definitions of conformance? Are you, in order to use a Kubernetes trademark, I think that's how it works. You have to you have to conform to the spec, and that can be evaluated programmatically. Is there a similar concept for AI? Is there like an AI, a cloud native AI conformance program? And if so, can I get how do I get that sticker?
Yeah, there is.
All
So
right.
first and foremost, I am
I think
not.
it should mostly be about who you know. Like if you know a guy, then you should be able to get that, you should be able to get the conformance.
Well,
That's
funny, and that you mentioned that the guy is you.
oh no.
It's self-reported, right? So yourself
Okay, great.
is going to get the stamp. It's not obviously the technical details have raised the complexity, but the actual reporting to be, we'll say, from the CNCF's AI certified. There's a set of like, I don't know, 15 or so rules, conditions that you have to meet, and it is self-reported. So it's things like, and I'm simplifying this, but there's 5 rules about how you manage, say, GPUs, right? They have dynamic resource allocation, things like this, but that's just is like, do you have some kind of monitoring of GPUs? Do you have some way to isolate on a GPU? Do you have some way to blah 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 blah, right? So you meet these 15 criteria, you report it.
Mhm.
Someone will evaluate it. Whether or not it's fully automated at this point, I actually don't know. So it's not too onerous,
Yeah.
at least, but it's also based on in this case, that's for Kubernetes AI conformance as a platform. There's also, one of the criteria for this is you must be Kubernetes compliant as a platform. So that has even more. And it's things like, do you have, auto scaling? Do you have, metrics gathering? Like, you have like all the kind of standard practices there. So it doesn't necessarily have to be a whole bunch of new things. 15 things isn't that big of an ask, especially because most of them are related to just managing GPUs, 10 out of 15 of them. And so, the base system is still quite important, right? Because again, other than training models, you're consuming and then running a bunch of agents, right? So like one of them is do I have an AI router, right, of some
Mhm.
form on my cluster? So it's meant to be high level because there's, if you make it too specific, you're going to lock the industry into doing one thing, right? We want variety. We want survival of the fittest solutions, and so that's why these things I think are deliberately a little bit high fetch. So it's not that high of a bar to get your platform AI certified. You just have to
It's
have a platform. That is hard.
right.
Right?
Right. Well,
Making your
in
own
that
version.
case, I'm happy to announce that all of Buoyant's platforms are all AI cloud native conformant and also, environmentally and ethically sourced and
That's right.
organic. We use only we use only organic bits. There's no pesticides that we spray on any of our software, um, except maybe emotionally. It seems like, okay, more seriously though, it seems like, with any kind of conformance or standards or anything, there's always a tension in technology where uh, the technology is moving rapidly, and the standards bodies are they're either criticized as like they're behind, because like the technology has evolved, so how are you ever going to keep up? Or they're criticized, and maybe this is even worse, like, oh, you're getting ahead. You're defining all these standards for things that like are still moving too quickly. And it seems like with AI, especially, if there's one thing that we know about AI, is that's an incredibly fast moving field. So does that affect any of this? Like, is there, how do you manage that balance in a world where things seem to be changing, from week to week, if not day to day?
So some of it is kind of continuation of what we've been doing. So one example is things like MCP comes along, right? And for those who don't know MCP, it's basically a specification on how we can proxy tools to, in theory, to agents. And so there's a
I
whole
heard they,
slew
I
of
heard they made it stateless. They just made it stateless, finally.
uh, yes, and also stateful. Yes. Um, yeah, and that's part of it, right? So it's like, some, in this case, Anthropic comes out with MCP. There was already others specifications not as popular, right? And then ultimately, it's kind of the first mover advantage, right? Because as you mentioned, this is all new and exciting and evolving. At first glance, you look at MCP and you're like, what is this? Like, don't we have REST? Right? Like this is, at some level, this is basically just REST. Like hit an endpoint, get a list of resources, and then execute them.
Let me
Right?
tell you, if you're a proxy engineer or if you work at a company that's proxy engineering, when you look at MCP, your reaction is much more disgusted than that. Your reaction is like, who the hell designed things this no, start over. This is all wrong. Anyways, please proceed.
Yeah. So, but that's the point, right? It's like we had things that are kind of already doing most of this or not, and then on top of it, you missed out on security right?
Yeah.
On step one,
You
which
made
is
it worse. In fact, you pretty much made everything worse. You could have like not invented anything and we would have been in a better spot than you putting this thing together. Like it is a reversion. Oh, I'm getting worked up about this. It's like a reversion in the industry because now we all have to like figure out how to parse it and handle it. And like we've taken a step backwards in so many ways with a stupid protocol. I apologize to everyone at Anthropic, big fan of Claude, but please do not design any more protocols. Or find some infrastructure engineers or find someone who has to write a proxy. Okay. All right. Go ahead, Ross.
yes, near and dear to your heart. So I think like we've seen this before, right? Like another example of like a change that comes and may get used or may not was first HTTP 2, but then quick in HTTP 3. Right. Some of this is behind the scenes, and most rank and file never see anything to do with something. But that's what's happening, right? Like people are building stuff that's getting subsumed. There's new groups to come around to management. So the Linux Foundation created the AAIF, the Agentic AI Foundation, which is parallel to the CNCF, and its goal is to manage all these concerns around AI agents. And so like MCP now lives there, right? Just like Kubernetes lives under the CNCF for bureaucratic kind of management. And so I think this is all expected and all good. What I fear, I guess, if anything, is that it's the big guys are winning this race, and there's going to be good and bad to it. So again, like MCP is what it is, but there's good and bad parts to it, right? Now they're adding sampling, which is basically reverse use of an LLM, which makes sense. But they put it in the spec, and then not to say anything, but the Anthropic's Claude didn't implement it. So if it's so needed, why aren't you like being the prototype showing us using it? Right?
Maybe this is like a poison pill where they're like, okay, we'll put this spec that's really hard to meet. We're not going to do it, but our competitors will have to spend a bunch of time on it. And meanwhile, we'll focus on making progress.
Yeah, so all I mean, and I'm not trying to dog them. It's just the popular, example. I think there's a lot of other super interesting things that are going to really blow this industry up to the next level, and that's around commerce. There's a great story out of a project out of MIT called Project Nanda, Nanda, and they're kind of, and again, I'm just paraphrasing because I'm not an expert on their project, but they're trying to look at the internet, and they're like, hey, what is it going to take to support 1 trillion agents? Right? The internet, we've kind of got some numbers and some idea on what it could support. We had the whole IPv4 to IPv6 conversation. There's just how many wires do we have connecting everybody on the internet, right? How much can we actually support? And then what I found super interesting was, I was like, I get the thought exercise. They're like, well, we can't make any changes unless we can find the use case that industry's going to pay for. And I'm like, yes, that also makes sense. And what one of the dimensions they've settled on, Professor Ramesh and crew, is basically a reverse auction. So they're not the first, but they're definitely making a pretty compelling.
Google famously does this, I think.
Yeah, that's right. It's so the idea for those listening is I have an agent and I want to go on vacation, and I got $1,000 to spend in these days. Go. So the reality is it's the agent. My agent's going to go talk to other agents and use its guardrails and its rules and its limits and negotiate with other agents. There won't even be humans involved, right? Until the day comes to go. And then when that day comes for your vacation, you're going to send your robot to go on vacation, right? It's not even
Sweet.
going
I finally don't have to go on vacation.
to, yeah, I mean, we've done it.
I can stay at home and relax while someone else sees the sights.
Right.
Wow, great. Just send me some
That's
photos.
right. So I think like that's, to me, is a compelling story. I personally am not that excited about e-commerce or anything like that, but I totally get why that would be an ideal use case, because that's where money is. Lots of parties are involved that make it work right. We have to be fair to each other, because if one person is like, screwing over another person, we're going to have rules to prevent that. So I think this is a very simple, compelling case that lots of people can relate to. And if we're going to have any kind of level of trust, we're going to have to get it right. And it's definitely not right today. But will we get it right tomorrow? Maybe. And that's the goal.
Yeah, that's a fascinating use case to think through, because obviously the agents on the other side are going to be incentivized to make money, and the agents on your side are going to be incentivized to, save money, and they're all going to be, like, yeah. And I mean, what is negotiation other than like presenting kind of the best possible case for why you should or should not change, this amount of money should or should not change hands.
I should add one thing to that. This is why we're still going to have jobs. And I don't mean just us programmers, but like people. Who is going to tell it what does it mean to be good, right? Like the buying and the selling, right? That's subjective, right? There may be some mathematical formula for some particular outcome, but more than likely that's only for a certain set of conditions, right? And our conditions will probably be different. So we're going to have influence. That means we're going to have to capture our intent. My buddy David Issa, who's always advising me on things, he's always reminding me, he's like, yeah, we're it's the intent that matters here. We don't care how it's done, right? It's what did you really want out of this? And so how do we capture that? And right now, most programming tasks are like build this API and very limited view of what probably the original intention was. That's just an implementation detail. So how do we better capture? And you could argue NLP, natural language. That's why we're able to feel like we're doing this. But humans, quite frankly, are pretty bad at it. Like, you could be like, I want to be rich. But then you stop right there and you're like, you have no mention of how or
Right,
any impact on anyone else, right?
Yeah.
Like, and so what does that actually mean? If we all say the same thing, we all have to like have our bots fight over that. Like, what does that even mean, right? So if the bots aren't, they could tell us, they could be like, hey, this is the best solution, but then they have to justify and explain that to you. And how do they do that, right? We got a long ways to go.
I feel like you so quickly get into these philosophical questions of like, what does it mean to want to do something, and what does it mean to, like, my immediate reaction is, well, I'm going to tell my travel agent bot, look, buddy, it costs like $5 a month in electrical bill to feed you. So like, if you don't save me $5, like, you're going to die. So go out and do it. Nah,
That's right. That's right.
you got to give it, it's got to have some skin in the game.
That's right. That's right. You cannot use my GPU anymore. Get out of here.
That's right. I literally won't be able to power you. I'm sorry. It's just, it's a tough world out there. All right. Cool. So I'll ask you, there's two questions I'll ask you, Ron, that I ask everyone, and then, we'll wrap things up after that. The first is, where do you see this all going? 3, 5 years, pick however far in the future you dare to predict. But especially, the parts around Kubernetes and AI. Like today, people are running inference workloads on Kubernetes. Maybe they're doing training on Kubernetes. I don't know. Agents seem to be mostly either running like directly with root access on your computer or in Kubernetes. Is that still going to be the case in the future? What's going to change about that? How does it? What's your prediction? Which, by the way, I'm going to play back to you in 3 years.
That's right. That's right.
Live on stage.
Yep. I'll we'll take it. I'm an optimist in this regard. Well, sorry, let me rephrase that. I'm a pessimist, but I'm optimistic we're going to fix it. So Kubernetes, there's a lot of parts to it. it's, to me, it's just another implementation of doing, distributed work. Is it the best? Is it the worst? Yes and no. Can we do better? Yes and no. And so because of that, I think it's like eating your own dog food. I think we're going to get to the point where it's not necessarily about how Kubernetes today is doing inference or how it's building things. The tools itself is going to optimize Kubernetes and all the things with it. Um, it's We have to be able to optimize and understand the systems. And so all of this is going to have to be largely automated at some level, because do you need to deploy 1,000 node cluster to do something when a 200 node cluster would have done it if you would have just adjusted like this, that, or the other, and timed it better, right? Things outside. I mean, yes, we have a scheduler and all that, but I think there's just going to be more intelligence to manage all these things, to know when to do it, like little finite things. Like if you know the boot sequence to things, you can game that system as well. And humans, yeah, you can kind of whiteboard some of this, but to dynamically do it all the time, you're going to have a system do it. And then, of course, again, back to, so what? You did something, aka optimize it. You have to prove it, right? And so, sure, what used to take 8 hours now takes 4 hours. Are we sure it's still correct? The output was 100 meg before, it's still 100 meg now. Is it the correct 100 meg thing we were producing, right? Like, how do you actually prove that? And at some level, you could be like, well, if you had confirmation tests before, just keep using the same ones and everything should be hunky-dory. That may work to a point, but I think as we go faster and do these kinds of optimizations automatically, the verification is going to become more involved. We're going to want to do it along the way as well, because we're going to get more ambitious. We're going to say, hey, if I could run on much less of a system, I can make more interesting things. And so, but now we're doing more, and that's again goes back to quick verification. I use the agents all the time to like help me do research and do things like this, and then I always find myself like, wait a minute, it gave me all these things, and now I got to know, is it correct or not? And part of that's just trust. It's just like a colleague, right? You're working with a new person. You better not trust them on day one, right? You got to trust but verify, right? There's no difference with a real person than there is AI. The difference is, no offense to humans, they're slower than the AI. And now we get so much more. We're going to have compensating tools for that. But I think we'll start to get there.
Yeah. Great. Okay. Final question for you, which is, if you are, if you're a person, let's say you're pretty up to date with Kubernetes and you're trying to just wrap your head around AI and like how this all works, not the bigger social concerns, because that's a lot to say there, but like how this works and what parts that you need to understand and how you need to think about stuff. What's your advice to those people? How should you get started just kind of untangling what's out there and having kind of a mental map or a lay of the land?
So there is a hierarchy of needs for your given job. I am a huge believer starting from the beginning is the way to go. So in this case, if I was new to AI and new to Kubernetes, what would I do? I would use AI to help educate me what Kubernetes is. Kubernetes got lots of great documentation, but if you printed it as a book, it's like 1,000 pages, right? Just know what you're talking about. Be able to, quite frankly, draw it on a whiteboard. Right? If you can't draw what the basic system is, you do not understand it, right? So forget about doing whatever else you were going to do, right? And then, if you just go from there, if you already know a bit about Kubernetes, use things like CacheGPT and its, spiritual replacements to just kind of analyze the system. Because, once you have a system, then you have like telemetry, right? And just the doing. Again, we're completely missing how you validate things, right? We have test-driven design in the Snap, but there's no tools. There's no common tools on how to verify. I could ask 10 people. Most wouldn't even have any guesses, much less say the same tool regarding verification. So again, we have to build those. So on the extreme end, we're just not there yet. But, operationally, can I use it to analyze things? Can I use it to just understand is the flow of the logs matching what I see in reality? By hand, forget automate, just question it and explore. We can do that now much more efficiently with AI, and that's what I love about it. I tell people specifically, like CacheGPT is a great example. It's an agent. There's more than one way to do it, but in simple terms, you can run it outside of Kubernetes, point it to your cluster. All it frankly does is proxy to an LLM. Takes Kubernetes events, says, tell me what's wrong, sends it to an LLM,
What
gets a
tool?
result. Hmm?
What's it called?
Kate's GPT,
Kate's
K8S GPT.
Okay. Yeah.
And so some people are like, it's too simple. It's just, taking text and going to an LLM with a little bit of a prompt. And I'm like, that's exactly why it's great. It does a little more than that. And this is probably the thing I just want to highlight. You can do simple things to help people. Is there's hard-coded checks. And so this is because these hard-coded checks came from a world prior to AI. They're just Kubernetes checks like, hey, what does it mean to have an image missing or this or that, right? There's like hundreds of checks. You take the events, you parse for these errors because they're known errors, you package it up, ask an LLM. Now, who is this good for? This, for me, is for the junior engineers. People think AI is for the experts and all that. No, this is to take junior engineer who doesn't really know Kubernetes. This gives you a natural language expansion of what experts already know. So now they can quickly get up to speed with doing literally one single Go binary, a key to OpenAI, pointing to your cluster, you're done. And now somebody who's never seen it is able to do way more quicker than they could before. And I think that's the wins you need. Like companies, we don't need artificial general intelligence today, right? We can just go with the little things. And so many people are skipping that step. It kind of boggles my mind. That's the free, easy step.
It's
They're
almost
like,
gosh, it is a much longer topic, but it feels like a lot of software engineering, whether you're on the DevOps side or on the like writing software side, a lot of it has been done under this apprenticeship model where like you learn by having, sitting next to the expert and like having them walk you through, watching them do it or having them walk you through it. And you have someone that you can ask questions of. And like when you're learning a new code base, like person sits next to you and like you're asking him or her, like, okay, what's going on here? And you kind of get a lot of that, with generative AI, or you can get a lot of that. Ron, I really want to thank you. This was a great conversation. Thanks for joining me on the podcast today. And is there any should people try and contact you, reach out to you, buy your goods and services?
well, contact me anytime if we can, I assume, share my email. But
Yeah,
just
let's-
contact anytime or LinkedIn. I look exactly how I look now. And so just I love talking about this stuff. And if you happen to be in San Francisco, happy to meet up. I can't get enough of this stuff. I loved computers before AI is really kind of reminded me why I love all this stuff.
Yeah, that's amazing. All right, thank you so much, Ron. Really appreciate your time today.
Thank you, man.
All right.
Bye.